Good day, my name is Ankama AN. I'm going to do a presentation on the review of hydropower generation at Maguga Dam. I will start the table of content. I will do a brief discussion on the introduction of the whole review, and then I'll also explain the various methodology that were used for deriving the results, and then I'll also give important results that not all the result, but most of the important result, and then I'll end the presentation with a discussion and conclusion on the findings. To start off with the introduction, I just want to explain that the multi-purpose dams are one of the most critical component of the water energy food nexus, in that they have the probability of achieving sustainable development using water resources covering all the three sectors of water, energy, and food. And these multi-purpose dams has the benefit of producing power and also using water for agriculture and other water supply development. And one of the dams that was carefully crafted for water energy food nexus is the Maguga dams, because it was specifically developed to supply water that can be used for energy and agriculture, and also for water supply in South Africa and Eswatini. So these dams well fit well within the wave nexus. So how the issue with the Maguga Dam is that it has been experiencing several drought events, which necessitated that a review needed to be done to establish if there is enough water, and also to establish the hydrological characteristic of its catchment. So the purpose of this review is basically just to do a hydrological assessment to confirm if there is available water for hydropower and other sectors, and also to make an assessment of a runoff river hydropower options to see now if this is one of the available options that can be undertaken. So the deliverable for this review, I've taken note of the 6 most important deliverables, which is now establishing a frequency duration curve where we can observe the flow over a certain range of exceedance probability. And then another review was on the dam characteristics, where the area against elevations and the volume against elevation was modeled and observed. And then from there, another deliverable for this review was to establish the full supply capacity of the dam and the full supply area of the dams. All these data were used to establish if there was sufficient water for storage dam hydropower, which is currently which has already been developed at the Maguga dams, and also to assess the option of the runoff river hydropower. And then after combining all this data, a comparison was made between the hydropower production of storage dam against the runoff river option. So these are the 6 main deliverables that were considered under this review. Now I will discuss briefly on the methodology that was undertaken to um, to achieve the to establish the finding of the deliverable that I have initially discussed. This review is basically a desktop study. It does not involve any field work, so it's basically based on the available data that were provided, which is the survey data, the the inflow, which is the hydrological data, and other equally important other data. So the instrument that was used is basically the study relied on four softwares, which is Quantum GIS, AutoCAD, Microsoft Excel, and also on Google Earth Pro. So basically, these tools were used to, and various these tools plus the various methodology were used to derive the findings. Now I briefly explain the method undertaken for most of these deliverables. The flow duration curve, Microsoft Excel was used to model the flow duration curve. Basically, the the hydrological data, which is now the inflow into the dam for the historical data were for since the 1920 up to 2009 was used to derive the flow duration curve. And the process undertaken was that these these data were converted into average monthly flow data, and then a line graph was plotted from which showed the flow for each month against the the flow for each month against the percentage of precedence. And from this flow duration curve, um, this flow duration curve was used uh, to to get the firm discharge that is required for the production of hydropower. In addition to that, the the study made use of quantum GIS with Excel to derive the area at each elevations for the dams, and also to derive the volume at each elevation for the dams. Basically, the topographical data were imported into Quantum GIS, and then the polygons at each elevation was created using various tools within Quantum GIS, and these polygons were were used to calculate the area at each elevations. This basically gave us a data that included elevation against the surface area at each contour lines. So the data that was generated from Quantum GIS was exported in as a CSV file and used in Microsoft Excel to calculate the volume at each elevation. So when the volume at each elevation was calculated, the the volume against elevation curve was plotted, and area against um, elevation was plotted to give to provide an idea of the dam characteristics in terms of volumes against elevations and area against elevations. And To move on, in order to establish the runoff river options, the topographical data was equally used using Google Earth Pro to establish the route of the canal that can be used for the runoff river assessment from the given diversion point to a point that needed to be located close to the dams. So the topographical data was used to see the most viable route, taking consideration uh, of the fact that the diversion structure, which is in this case is presumed a canal, need to flow with gravity from the diversion point to the abstraction point. So the various tools were used in Google Earth Pro to observe the terrains from the diversion point to the abstraction point, and also to map up the road that the canal can take. So from there, an abstraction point was determined based on this, which also has which was also made to have the same gross head as the dam storage hydropower production. So based on this assessment, the canal route was established, the abstraction point was established, the road, the penstock road was as well established, which is now from the abstraction point to the powerhouse. So all these parameters were determined using Google Earth Pro and the topographical data that were given. In order to do a comparison between the storage-based hydropower and the runoff river hydropower, the two hydropower firm discharge were established, and also their firm power potential were established. So the firm discharge for the runoff river hydropower was established from the flow duration curve, and for the storage dam it was established from the water usage that can potentially run through the turbine when water usage for all the sector is released from the dam. So then the power potential was established for these two options. So moving on to the result, this is the frequency duration curve. From here you can see that the probability of exceedancy for 90%, 95, 96, 98, and 99 were obtained from the frequency duration curve, and these values were compared with the water demand of the current setup of the hydropower Maguga dams. What came out of this comparison is that the the flow discharge from the FD indicates that the available water at a given percentage of exceedance is way less than the water demand that is forecasted, meaning that it is indeed true that there is a shortage of water, and the water demand that has been forecasted by the various sectors for the dams cannot be met uh, based on the hydrological historical data. So it need to be reviewed. That's basically what the frequency duration curve is trying to explain to us. Moving on, looking at the hydrological parameter that we calculated, the total storage capacity of the dam was estimated to be around 284 million cubic, while the full supply capacity, which is now the total storage capacity, uh, uh, sub, which is now subtracting the dead volume from the total storage capacity to give us the full supply capacity. So the full supply capacity came roughly at 283, which is slightly than less than the total storage capacity, while the full supply area was around 8.8 square meters of areas, and the gross height was estimated to be 95 meter, and the variable drawdown height was estimated to be 75 meter. Yeah. The other thing is also the dam characteristic was observed in terms of elevation with area, and it was observed that the the areas increases in proportion to the increase in elevation, meaning that the dams have quite a smaller surface area at the bottom of the dam, but as the elevations start to increase, its area also start to increase, meaning that at the bottom there is quite a small surface areas, and the big surface area, meaning its potential for storing water, is at its highest level. Equally, the volumes with elevation um, graph curve also indicated that the dam um, volume was increasing with proportionally to the increase in the elevations, demonstrating that most of its volume is at the higher level of the dam. This is just to This information is important in forecasting drought events and also establishing how the volume of the water increases or and decreases with the elevation. The main component of the study was now to establish the runoff river options. Uh, the image there shows the canal road which was established. It also shows the abstraction point which was also determined, plus the penstock, and it also indicating that the canal length was estimated to be 18.5 kilometer, while the uh, canal while the penstock was 780 meters. So the different location for for the point that were estimated are also provided. So when the runoff river power potential was calculated, it was established that the runoff river has only a potential of around 4 megawatts of power, while the storage dam power potential was at around 18 megawatts, which indicate that sorry that the storage dam based power production, which is currently what's happening in Maguga Dam, has more power potential than the runoff river. So this was one the main issue that was supposed to be the main reason for doing the review, and it has given this result that storage dam has more potential, but it has also given that the storage dam, the water sector's water demand cannot be met by the dam because of drought event, because and the hydrological characteristic of its catchment. Just to have a small discussion and conclude, the conclusion here just say that The, the catchment area of Maguga dams has indeed challenges of droughts event which does not equate to the water demand that the various water sector want to extract from the dam. That's one of the findings. And also, the main finding as explains area is that hydropower system is found to generate more power than the run-of-river hydropower. And then the storage dam system also has the benefit that water can be used, water that has been uh, run through the turbine to generate electricity can be used for other sectors such as agriculture and water supply and development. And this basically implies that the current system of hydropower generation at Mangunga is the right one and the most viable one when compared with the runoff river. I thank you very much, and this is the end of my presentation. I'm not talking in terms of content. Did I even record? Why did you not? It's in terms of